Earth, a 4.5 billion year old planet, still evolving. As continents shift and clash, volcanoes erupt, glaciers grow and recede. The Earth's crust is carved in numerous and fascinating ways, leaving a trail of geological mysteries behind. In this episode, investigators are exploring the driest place on Earth, the Atacama Desert in Chile. This barren landscape is 50 times drier than Death Valley. Now, scientists are piecing together the puzzle of how this desert was made. From raging volcanoes to colossal mountains, oceans, the clues they uncover also provide a window into the formation of the Earth itself. Earth is a blue planet, engulfed by water. But in this desolate chunk of northern Chile, you won't find a single drop. Wedged between the Pacific Ocean and coastal volcanoes to the west, and the Andes to the east, is Atacama, the driest desert in the world. "600 miles long and narrow, on average just 100 miles wide. It's the same size as Iowa. Now, scientists are on a mission to find out how it was made. The investigation begins in the sleepy town of Quiagua, a rare green oasis. Its only lifeline is a stream, trickling 300 miles from the Andes to the Pacific. It is home to the official government rain gauge, so geologist John Houston has come here to find out how dry the driest place on Earth really is.
This is a pluviometer. It measures the rainfall every day.
Ah, okay.
For Marissa Vera, a government scientist, it's a job with few surprises.
How much rainfall has this instrument recorded?
In the last 15 years, less than 1 millimeter by year.
Less than 1 millimeter a year?
Yes.
Was it every year?
It rains only 3 years.
That's incredible.
Exactly.
So less than 1 millimeter a year.
On average, it rains 3/100ths of an inch a year. It would take a century for Atacama's rainfall to fill a coffee cup. How does this compare with other deserts?
Here we have a cylinder, and I'm going to show you the difference between the amount of rainfall per annum here and the amount of rainfall in other deserts. So if I fill this jar up, right up to about there, that is roughly rainfall that you get in the Sahara. Now if I pour most of that away, we get to that level. That represents what we have in the Mojave Desert, 5 inches per annum. If I pour all that away, except for that little drop in the bottom there, and that's the equivalent of what we have here in the heart of the Atacama Desert. That is such a small amount of rainfall that it means it's the driest place on Earth.
In his quest to find out why Atacama gets so little rainfall, Houston leaves the oasis behind and heads into the desert. By the side of the Pan American Highway, a road which runs the length of the continent, he discovers the first clue.
Well, here we are at the Tropic of Capricorn. This is one of the most important latitudes in the world, and it is absolutely critical in explaining why the Atacama Desert is in this location here.
Most of the world's deserts straddle one of two special latitudes. In the southern hemisphere, the Tropic of Capricorn runs through Atacama and Africa's Namib and Kalahari deserts. In the north, the Tropic of Cancer runs right through the vast Sahara. At these particular positions on the planet, the air is extremely dry.
This instrument is called a whirling hygrometer. What this does is to measure the relative humidity of the air. And the reading on here gives us a relative humidity of 10%. That's really low, really low. There aren't many places in the world where you get a relative humidity as low as that.
Back in the early 1700s, scientists discovered why tropical air is so dry. European ships sailing to America relied upon the trade winds to power their crossings. But English meteorologist George Hadley was mystified why they blew westward when they should blow directly north. His studies would lead scientists to understand how air circulates around the Earth. At the equator, moisture-rich air gets heated by the sun and rises. As this hot, wet air flows away from the equator, it quickly sheds its water as rain. By the time it reaches the two tropic latitudes, the air has lost nearly all of its moisture, resulting in no rain on the land below. The mystery, though, is why Atacama gets so much less rain than any place else. Scientists hope to crack the case by figuring out how Atacama first formed. On the hunt for clues, Houston travels deep into the true desert. This closely guarded location was discovered during routine mapping by geologists back in the 70s. But the huge significance of their find wasn't realized until 1998. This band of boulders is the single most important clue to Atacama's beginnings. It's a delicate rock called gypsum. A simple test shows how fragile it is.
If I pour a little bit of water on top of that, you will see that it very rapidly falls apart. What's happening here, of course, is that when I'm putting water on this, you see it dissolve. I mean, it's just going to fall apart.
The survival of gypsum as a solid rock tells scientists there hasn't been any heavy rain since the rock formed. So the next step was to date it and figure out when this place became dry. Gypsum can't be directly dated, but by analyzing fossils in the surrounding rocks, the awesome age of the desert was revealed. Atacama is a staggering 150 million years old.
This gypsum here is an extremely special gypsum. If there had been any rainfall greater than 2 inches in any one year, this would have dissolved and have been washed away. What that means is essentially that the Atacama Desert is the oldest desert in the world.
For more than 150 million years, while dinosaurs thrived and became extinct, the Himalayas formed and humans evolved. Atacama has been a desert. Gypsum also holds the key to how this desert was made. It's a chalky mineral which forms not in deserts, but in water. Gypsum exists in a dissolved state in shallow, warm, tropical seas. As the water is evaporated away by heat, it solidifies. The existence of this one little rock is a key piece of evidence which reveals that before Atacama became a desert, it was a seabed.
This really insignificant looking piece of rock indicates that all this desert was once underwater. So this gypsum in this location in the Atacama Desert is absolutely critical to understanding the whole history of the Atacama Desert.
In the investigation so far, scientists have pieced together evidence of how and when the desert first formed. Atacama's location near the Tropic of Capricorn means air is dry and no rain falls. Fossils found in the surrounding gypsum rock reveal the age of the desert. Gypsum, a rock that forms only in water, reveals Atacama was once underwater. Now, as scientists explore the mystery of how Atacama evolved from ocean floor to pure desert, they unearth explosive evidence in the investigation of how the driest place on Earth was made. "150 million years ago, the Atacama Desert was a seabed covered by ocean waters. But today, some areas in the desert are 2 miles above sea level. In the journey to find out how this happened, scientists take the investigation to the eastern edge of the desert. This strange landscape is the largest geyser field in the southern hemisphere.
We're up at the Atacama Geyser Field. You can see around us that there's plenty of hot springs and geysers. There's plenty of steam around, and this is because the air is cool and the water is hot, and so you have a lot of steam and bubbling springs.
The boiling water is being heated deep underground.
The geysers and the hot water that you find up at El Tatio are indications that you have a body of hot rock underneath us. And another indication is you have a bunch of volcanoes surrounding this basin.
The earth here is violently alive. Molten rock erupts onto the surface, forming volcanoes. The fiery volcanoes and the boiling geysers are evidence of a turbulent process happening deep beneath the desert. Here, the Pacific Ocean crust is being forced underneath South America, much like a spatula going underneath a pizza. This geological process is called subduction.
You have the Pacific plate colliding with the continental crust, and the Pacific plate is actually heavier and it slides underneath the continental crust. And as it does so, it heats because it gets to a depth of about 60 miles and it becomes molten.
This crucial depth is called a melting zone. Hot molten rock then thrusts upward to form the active volcanoes that ring the El Tatio geyser field. This process gives scientists a hint to what lifted the desert out of the ocean. More clues are found on the opposite side of the desert. Geologists know that these coastal hills were also once volcanoes. Today, they're completely dead, but modern dating techniques show that they first erupted over 195 million years ago. It's a crucial piece of evidence which reveals when the Pacific Plate first began to force its way beneath South America. At that time, the desert, indeed all of Chile, was underwater. Over time, the melting zone was pushed further and further inland, first igniting the coastal volcanoes. As the melting zone passed beneath the desert, it formed new crust, thickening and raising the land. The Atacama Desert slowly emerged. "50 million years ago, this same process began to raise the Andes. Today, the melting zone is 140 miles inland, and the molten rock it produces ignites volcanoes and fuels El Tatio's geysers. But as it passed under the Atacama Desert, it also left behind this: Chuquicamata, the largest open-pit copper mine in the world. Volcanic processes concentrated the copper ore here, but it was the desert's unique climate that locked it in place.
This area of northern Chile produces some of the largest and most important copper deposits in the world, and this is largely due to the very dry climate. Most of the erosion on the Earth's surface is caused by water. So here, where there's so little rainfall and there's very little surface water, there's not very much erosion, and so the copper deposit has actually remained intact.
As a result, this barren wilderness is one of the most valuable pieces of land on the planet. The mystery of how a desert can rise from the sea can be solved. Geysers provide evidence that molten rock exists deep underground. The existence of active volcanoes shows the movement of one continental plate under another. Extinct volcanoes show this process began at the coast and pushed inland, raising the desert above the ocean. The next step is to try and figure out what turned this ancient seafloor into the driest place on Earth. A quest that spans 200 years of history and solves the riddle of what brought these penguins to the edge of the desert. The Atacama Desert is intriguing because it is the driest place on Earth. Deserts by their very nature are dry, but Atacama is unique. It's 50 times drier than Death Valley in California. And it's not because it's hotter. Atacama averages around 80 degrees Fahrenheit during the day, whereas temperatures in Death Valley regularly soar above 110. The search for what turned this strip of land from a regular desert into the world's driest place begins out on the open sea.
One of the curious things about the Atacama is that we actually see here penguins. Penguins obviously like cold water, and that's really confusing when you think of on shore we have really hot conditions. In fact, the temperature of the water here is about 55 degrees Fahrenheit, whereas on land the temperature is something like 80 degrees Fahrenheit.
These penguins were first described by explorer Alexander von Humboldt over 200 years ago. While traveling along this coast, he was puzzled by the huge variety of marine life. Measuring the temperature of the water gave him an explanation. It was 20 degrees colder than expected, perfect for sea life like penguins. Centuries later, meteorologists began to wonder if this chilly belt of water, called the Humboldt Current after the explorer, was the reason Atacama became the driest place on Earth.
The Humboldt Current comes all the way up from Antarctica, bringing with it cold water. And it is this cold water which creates this dull grey day that we see here with a fog overlying us.
It causes the air above it to cool, forming a thick bank of cold cloud and fog which clings to the shore. Hot, dry air descends at the tropics. Here, that hot air sits on top of the cold, heavy rain clouds, holding them down. Meteorologists call this an inversion layer. Trapped at 3,000 feet, the clouds can't rise up and shed their rain on the high-altitude desert.
The inversion layer prevents any moisture that may accumulate close to the sea from moving inland. So that is one of the reasons why this Humboldt Current actually contributes to the dryness of the Atacama Desert that we see just over there.
But is it this inversion layer, created by the Humboldt Current, that has turned Atacama into the driest desert in the world? In the desert's northern tip, in a desolate place called Quebrada Aroma, geologist Laura Evenstar is looking for clues to solve this riddle. She's trying to put a date on when the desert became so very dry. Other deserts, like the Mojave, don't get much rain, but when they do, it's dramatic. Storms bring heavy rains and flash floods. But not here, in the Quebrada Aroma, which is now totally dry. One way to date the last time there would have been enough rainfall to cause a flash flood is to try to find out how long the rocks have been lying there undisturbed.
What we have here is a miniature demonstration of what goes on if we start having large amounts of rainfall. So this is our rainfall here. And what we can see is that when we start raining on our desert surface, it will pick up the boulders and move them around. And then when there's no water here, the boulders just sit still and don't move.
The surface of Quebrada Aroma is strewn with rocks, so she's cracking them open to reveal evidence of exactly when water last flooded the landscape.
What we do is we have to knock a bit off and then we examine it and have a look at whether it's got a very dark colour, and hopefully we can be able to see some of the black minerals, which is what we're looking for.
The tiny black crystalline minerals are pyroxenes. They're crucial evidence because, like microscopic geologic clocks, Their chemistry changes when exposed to cosmic radiation over time.
The sun is only producing a tiny bit of the radiation which will hit this rock. The majority of it is coming from all the stars you see in the night sky. What it does to the rock is basically just bakes it, a bit like a really bad suntan. So it just comes down, hits it, and cooks it.
As the rock gets cooked by cosmic rays, the pyroxenes break down and produce a gas called helium-3.
We can record how much helium-3 is within this rock, and the more we have, the longer that it has been exposed to cosmic or solar radiation.
Helium-3 gas is only produced in microscopic quantities. So Evenstar takes her samples to a lab 7,000 miles away in Glasgow, Scotland.
So what we do using a laser is we shoot the laser into one of the wells and vaporize our crystals. And that's releasing the helium-3. Then the helium-3 is going to go through all this complicated machinery, eventually run through the mass spectrometer.
By analyzing this data, she can figure out the last time the boulders were moved.
The oldest age sample we've actually recorded has been 23 million years. So what this means is that within certain areas of the Atacama Desert, these boulders have been sitting there and not moved by water for 23 million years. So the Atacama Desert is one of the oldest undisturbed surfaces in the world. These boulders were there before humans even started to exist. They are incredibly old.
Evenstar has discovered that there are places in the desert which have been bone dry for 23 million years. This date is a crucial clue in the investigation because it coincides with the birth of the Humboldt Current. South America was once joined to Antarctica, but roughly 25 million years ago, these continents split. A channel opened. Freezing water began to circulate round the pole and thundered north along the coast. This cold current formed an inversion layer, trapping coastal rain clouds and starting Atacama's slow transformation into the driest place in the world. But the Humboldt Current is not the only culprit. Ironically, the quest to find out how the desert became so dry comes up against one of the wettest places on Earth. On the other side of Atacama is the Amazon, but the heavy rainfall from the rainforest doesn't get anywhere near the desert. The reason why is in plain sight. Between the Amazon and the Atacama Desert lies the vast Andes mountain range. Geologic evidence suggests the Andes finally grew high enough some 10 million years ago to prevent any rain from reaching the desert. It's called a rain shadow effect, and it's the final factor which drove Atacama to become the driest place on Earth. The evidence for what turned Atacama so incredibly dry is mounting. The Humboldt Current creates a weather system that allows no rainfall. Helium-3 in rocks shows that the process of desiccation began 23 million years ago. The rising Andes, 10 million years ago, made it drier still. The investigation would seem to be conclusive. Atacama has been a barren, essentially rainless landscape for millions of years. But then, something happened to blow that conclusion wide open. Tiny shards of stone revealed that an ancient civilization once lived here. But how could people live in the world's driest desert? The Atacama Desert is by far the driest place on Earth. And by piecing together the evidence, scientists believed it had been so for millions of years. Yet, at a remote site called Guanaqueros, paleoecologist Claudio Latorre made an intriguing discovery which paints a more complex picture.
This is an extraordinary find, and this was probably a little knife or a scraper that's been broken off and discarded. That could probably still cut.
To the untrained eye, it looks like a simple rock shard, but Latorre can see it's been worked into a tool. And he's found hundreds of them. They're clues that reveal ancient humans once lived here.
This was not just a temporary residence. This was something where people were living and working and banging away at rocks and making artifacts and living off this landscape, using the resources at hand.
As water is essential for life, it seems impossible that any kind of plant, animal, or human life could survive here. Latorre suspects that some regions of this 57,000 square mile desert were once much wetter. Not millions of years ago, but during the time humans walked the earth. In 1997, he set off on a mission to hunt for evidence. Today, he's retracing that journey. Changes in the climate can be seen in the rocks, so Latorre examines the cliff layer by layer. He finds a crucial piece of evidence.
This is actually where the interesting part of the story comes in.
This chalky rock is called diatomite. It's made from the crushed remains of fossilized algae, microscopic life forms which only live in fresh water.
What this rock is telling us is that we had basically a wetland. Whereas you look at the landscape across the day, and we see that it's basically about as dry as you can get.
Sometime in the past, there was water on the surface of the desert. Latorre's next task was to find out when. Radiocarbon dating is one of the most accurate methods of dating. But using this method means sampling something organic. So Latorre combed the desert for clues.
The way we work is basically poking our heads into every little hole and crevice that we can find. When we found this place, we couldn't believe our eyes.
He accidentally and luckily stumbled upon the most important piece of evidence in this investigation. At the back of the cave was a vast nest. It's made from the feces of thousands of generations of tiny mammals. The size and shape of the pellets told Latorre those animals were chinchilla rats. And it also contained the critical clue he was searching for: organic material.
When we found this site, one of the most exciting discoveries that we made was the fact that it's full of grasses. Now look across the landscape today and tell me where those grasses are. And we immediately knew that we were talking about some major vegetation change.
This grass looks as fresh and crisp as if it was collected yesterday. But when Latorre carbon dated grass from the nest, what he found was amazing. The grass was more than 11,000 years old.
What I have in my hands here is an ancient ecosystem. This is about as clear an indicator you can get, better than anything else you can think of, that water increased in the past in this area.
The nest reveals strong evidence that plants and mammals did exist here. And they weren't alone. Underneath the thick layer of nest is another layer, rich with tiny handmade tools.
If we look around, we can find actually evidence of this past human occupation. There's just full of little shards here on the floor.
Some regions of Atacama have been constantly dry for 23 million years. But this evidence shows that other regions, like Guanacaros, were very different 11,000 years ago. It's a fossilized snapshot of a diverse ecosystem briefly bursting into life. Grasses grow and wetlands flourish in this wetter time. Tiny mammals thrive and breed, while game, like vicuña and llamas, meant humans could live in this rich and fertile environment.
So it's wonderful to know that by looking at something as mundane as a rodent nest, you can actually find clues that enable you to understand the past human colonization of the Atacama Desert, which is no mean feat in itself, given the fact that it's such a harsh climate today.
The date of the rat's nest gives scientists a possible theory of where the water came from. 11,000 years ago, The last ice age was at an end. The global climate was changing. More rain fell high in the Andes, flowing down to the desert in rivers. In some places, groundwater pooled, forming wetlands. Others remained untouched by water, as they had for millions of years. But just 1,000 years later, the climate changed again. Rivers dried up, grasses died, rats and humans disappeared. Now every drop of groundwater has been sucked down into the parched earth. Latorre demonstrates how deep that water is today.
So just to give you an idea of how much change has gone on since the wetland was formerly at the surface, here's a little experiment that we can do. This is a well, and I'll drop this little rock, and we're going to count, and we're going to see how long it takes for that rock to hit the water. So that takes almost 4 seconds to reach the water. That's well over 200 feet below the surface is where the water table is today. It's about as dry as it gets. It's what we call absolute desert. No plants, no wildlife, nothing. No surface running water whatsoever.
The investigation of this driest place on Earth took a surprising turn. Tools show humans lived here. Diatomite reveals the climate was once wetter. Rat's dung and grass dates a diverse ecosystem to 11,000 years ago. Yet this extraordinary desert has more secrets to tell, not just about life in one of the most extreme environments on our planet, but also about life on other planets. Today, scientists suspect Atacama is the driest it has ever been. So they're investigating whether there's any source of water left here at all. And NASA scientist Alfonso Davila knows that if there's water, there's a chance there could be life here too. But when he first arrived, the signs didn't look good.
When I came here for the first time, I drove for a couple of thousand miles, and when I got back to my base camp, I realized that I didn't have a single insect smashed against my windshield. That has never happened to me anywhere else in the world. And I think that's a very good example of how hard this environment is for life.
Since the 1960s, NASA scientists have been hunting for bacterial life in the desert's thin soils, yet they found nothing. Until 2005, when they came across a strange white landscape. By chance, one of Davila's colleagues picked up a rock, smashed it open, and discovered something completely unexpected.
Yeah, you can see very nicely a green layer inside the crust.
Under the microscope, the significance of this pale green blur zoomed sharply into focus.
To our surprise, we saw a green microorganisms living inside the rock. So that came as a big surprise because nobody was expecting microorganisms in the middle of the driest place on Earth.
Completely by accident, hidden inside a rock, they discovered life.
This mineral is sodium chloride, otherwise known as halite. It's a very common mineral in the Atacama Desert, and it's also a very common mineral in kitchens around the world, as this is exactly the same salt we use to spice our food.
Salt can preserve food by killing off bacteria. But here, strangely, it was harboring a colony of green microbes. To find out how they survive, Davila laid out a series of sensors that measure humidity. His research shows that although on average the air in the desert is around 10% humidity, on rare occasions it rises as high as 75%. This momentary increase in water vapor is the only source of water. And it's this water that gives rise to life.
The distinctive property of salt is its capability to extract water vapor from the atmosphere and forms a liquid solution inside the rock.
As moisture from the air is sucked into the salt, the microbes allow the rock to bring the water to them.
Life is actually very robust. It's very flexible and it can really adapt to some of the most extreme conditions that we see on Earth.
NASA believes this discovery in the Atacama Desert can reveal something about life on Mars. In 1976, the Viking lander detected water in Mars's thin atmosphere. In 2008, NASA's Mars Odyssey orbiter found evidence of salt on the planet's surface. Now, when humans finally get to Mars, they won't be looking for life in the thin Martian soils, but inside the rocks.
Unfortunately, it's going to be a long time until we see humans walking on Mars. Until then, we come to the Atacama Desert and we study this type of rocks, which likely hold the clue to understanding life on Earth and also to understanding the potential for life in other planets in our solar system.
So, it's possible that an accidental discovery in the driest place on Earth will one day lead scientists to crack open a Martian rock and discover little green alien life. The investigation into how the driest place on Earth was made has revealed an awesome Earth story spanning 150 million years. Gypsum, a rock which forms in water, shows the desert was once a seabed. Hot geysers show that immense volcanic activity under the desert raised it above the ocean. Tiny pyroxene crystals reveal the first areas of the desert which became completely dry 23 million years ago. Rat nests reveal a small pocket of life that bloomed in the desert at the end of the last ice age. Tiny green organisms in salt show that even here, life clings on. Today, this place is unique on Earth. Absolute, perfect desert. And the investigation into how it formed has shed light on another chapter in the story of how the Earth was made.